Doctori, tutto a posto? So welcome back to a new video. The topic for today will be the asynchronous I/O library called SC Async. And this is a library of Sane C libraries, which is this project I have been sharing on GitHub that you can go and download or clone if you prefer. It's a platform abstraction set of libraries for macOS, sorry, Windows and Linux. It's fast to compile, it's bloat-free, it's simple and readable and easy to integrate. It doesn't use the C++ standard library or exception or runtime type identification, and there are no third-party dependencies. So make sure to watch it, and you can also join the Discord, which is linked into the description below, and it's also linked here into the getting in touch. So make sure that you are really following the project if you would like to get notification about new things like the one we will be doing today, which is implementing an ep.11 backend for SC Async library. So I have prepared this for a while. I was really trying to understand how this could really be working, and I created this equivalence, this kind of table of functions I should be using in each phase. Of course, I've been reading all of the documentation for the IOU ring, and I think I have a pretty clear idea of what to do. So this is just the monkey coding implementation phase, and I think this is cool. So yeah, actually this is what I like, because when you really have an idea on what to do, that's where really the fun begins. So um, let's create an implementation file for this backend. So let's call it maybe async linux.enl, because we already have POSIX, which was the old, not old, I mean it's the current ep.11 backend for Linux. So, but ep.11 I think it's used on some other OS, not really 100% sure. But the IOU ring is for sure something Linux specific, and I'm gonna call it Async Linux for now. So I'm copy pasting the empty implementation of mscript10. So let's see if this is even compiling. Async linux.enl compile. Boom. All right. So this is cool. Now I am first thing I need to do is to include the liburing, which I think I have been doing some sort of sudo apt install liburing, and this is kind of fun because this liburing is a project on GitHub, which you can see. So it's, even if it's let's say the official API, it's only provided as a set of syscalls at a very low level in Linux, and it's kind of not easy to use because you have to make sure that you are putting memory barriers in the right spots. So they created this sort of, they call it higher level library, but it's just a regular API. But instead of distributing it with the let's say with the compiler toolchain or with the glibc, you have to install it yourself or download it and compile it yourself. So I don't know, that's the Linux way of doing things. Honestly, I feel this should really be part of the glibc, but for some reason this is not. So first problem that this is one that I've already found, is that when you are compiling in C++ mode, this library would like to include atomic, which we can't, as in our makefile we specify a no std inc++, which doesn't allow us to use the standard library. So I'm not going to give up to my project requirement just for this. So what I think we can do here is to just define these functions and replace them with something that could make sense, and define this lib barrier And I guess this is extremely ugly, but it works if we do it right. So I'm not really sure what are the types that are needed. I don't think they are going to need explicit atomic operations for everything. So let's try to do something about it. Let me just return 0 and return 0 also here, because I want to get the correct types for all of the signature. Maybe we can replace this with just int32, and if they need anything else I will replace it. I think I did this when figuring out how to include liburing without needing to use the standard C++ library. But let's see. So of course we need an std int if we would like to use that, and they look pretty good. No, there are invalid conversions, so they have unsigned int, in which call in the SMP store release. SMP store release, so this should be unsigned int. So this is a uint, sorry, and this is a uint. Which one also? Load acquire? Sure, no problem, sir. And the right ones wants an unsigned int as well. So they are all uint. Okay, I was remembering something wrong. Very cool. So I now need to do an explicit store with memory relaxed order. I may have in the atomic library the little bit of code that should be doing that. So for the load we can definitely do this. Load explicit. Is there a load explicit? Let's search it. Atomic load. Atomic load with memory order. Also, the memory order is relaxated. No, this is load n. Is there a load explicit? No. I mean, I can review this offline, but for now, no, I think this is correct. So I need so value and result. So result, this is the output. So they have input and output. So input is the var, output is the res. Okay. And we want the atomic order relaxed. This one. Right, and we return res. Does it sound right? Yes. Now this is the load acquire. Sure. So this would be P, this will be acquire order, which is atomic acquire. And all right. Now we need the store. Atomic store release. Atomic store. Let's just store. So we want to store, hopefully this is the, let's just make sure to get, stores the value of val into PTR. So PTR is the destination. P, destination, and V is the value. And this needs to be on release order. atomic release. All right. And now we need a store with relaxed order. All right. Yeah. Var and val. All right. This looks doable. So relaxed. Yes, we have this. So this is a store. This is an explicit load with a relaxed order, and that should be right. And this is a release, and this looks correct. And this is an acquire. Perfect. So as you can see, we avoided including this atomic header. So I will review them maybe later with spending a little bit more time just to make sure I'm not messing up some of the flags, but I think for now this is cool. So next, create and close. We have to init and we have to exit the library. Not sure where I really will be able to bring this, but let's see if at least a couple of the first tests can be made to run. So IOQ init, we need number of entries. Let's say const static const integer q sides. I don't know. Let's make some just a constant so we don't hard code it here. We need to store this IO ring ring. We are on the ring. Not sure if I will need this loopfd, but well, let's see. Maybe not. I don't know. Let's see if ring, yes, flags. I don't think I need to pass any flags. I have been reading the flags and there was nothing that was interesting for me, so no, I will not be using any flags. So this is clearly a POSIX style API, so there is a result. If res is negative, return error. Let's just say, yeah, this one. Oops. All right. We have a static assertion of the size of our yes, of the space for this internal object. From 168 we need to be 224 for now. Probably it will be even more later, but for now that's right. And in the close, I would like to close it. You ring, exit, yeah, exit the ring. Okay, first thing is linker errors. So I mean, we can do it in many ways. I don't know if maybe I can add into the tasks for now hard coding. I think this is the job we are using. We don't need this nproc here, I think, so I can remove it. LD flags, LU ring. So this should be in the make file. Let's see. Make file, ld flags. No, just yeah, it's the last one. It's the system one, the one that is supposed to be overridden from the outside. So this works. All right, this is just standard Linux POSIX, way of doing things. I will think about adding support into the makefile to link this, but for now I don't want to waste time on this. So what else? So we created, we linked, we made the atomic operations. I need to create the timeout, right? So let's try to implement the timeout. So how do I implement a timeout? What's the function for it? It's called, well, I should probably implement all of this other stuff first, but yeah. Let's do it backwards. So we need to have a timer, a timeout, and a timeout remove. Okay, cool. How do I do that? So the way this works, I think we have to create all of these operations into the activation phase, because they are always fire and arm, and then it's fulfilled, and if you want to, you have to fire it again, which means activate it, or you can cancel it if you don't really want to have this async operation running anymore in the kernel. So I'm going to make this async time loop timeout. Yeah, async loop timeout. And for now, this should be compiling. So prep timeout, I need IOUring SQE, which is a submission queue entry. How do I create an entry? I think, yeah, let's create let's say IOUring SQE create submission. So what is the create submission doing for us? I think we need the async event loop. Yeah. So from the event loop, we can get the internal, and once we get the internal, we get the ring, and we have our IOUring ring. To get a new submission, there is IOUring get SQE that wants a ring and returns an IOUring SQE. It's called submission, or maybe, yeah, kernel submission. Yeah, return kernel submission. I think this can be false, but yeah, we'll take care about it. I mean, it can be null PTR if this fails, because this is a ring buffer, so if you have too many completion, this can clearly fail. It's even documented. I've been reading it, so, but for now I'm just going to ignore it. So I can create a submission. You know what? Let me make this fallible. So this is a result. No discard. I guess by now you should know that I would really like to have a no discard by default feature in the language, but I don't know. I will leave. I think I will do the best I can with what I have. So we can try this, and with our async async dot event loop and submission. So we can prepare timeout with the submission. Oh, we have some fancy parameters to return here. So here we have to return result true, and submission is kernel submission. So we can do handle case where kernel submission is null ptr. Yeah, so we don't forget. Now I need a kernel times back. What is a kernel times back? Let's see. This looks like just a times back, I would say, which is the same we are using here. Yeah, and this is all right because our high resolution counter is binary compatible with that, because it's made of two uint64, which I suspect is the same that is being used by this kernel times back. Yes, it's a times 64, which is a long, which is a 64-bit, and long, again, 64-bit. So kernel times back is binary compatible with time, what's called high resolution counter. Yeah, maybe let's add some static assertions. Maybe I'll just add one static assert that, I don't know, built-in, what was it? Built-in offset of time resolution counter part 2 needs to be the same as built-in offset of kernel times back, which was the second one, and sec. Okay, let's see if this holds true. Of course, you have to do it this way. Doesn't like this one. Oh, I need to make it equal. All right, event loop. Oh, so event loop is a get event loop. Can you, is it still a pointer? Oh, okay, can make it this way. Cool. So I will add some more, but this is clearly compatible. Why do I care about this? I care because I have seen that all of these functions, they require they take pointers to this data structures, but they state that the time spec must be valid for the entire duration of until you submit. So must remain valid until the request has been successfully submitted. So I don't know where to store this, because of course there is this, we cannot just allocate stuff, because this library has this, do not allocate rule, the async library. So I will just do async dot expiration time, which is a high resolution counter. So I will do something terrible, which is reinterpret cast of this one to be a kernel times back. Yeah, This is terrible, but I guess I don't have a better choice for now if I don't want to allocate. So let's do it. Oh, I think this is just a pointer, so maybe let's keep it a pointer. What else do we need? Count. This is the number. This API says I will time out when kernel time spec is amount of time is passing, or when number of completion entries are fulfilled. And I don't care about the second, so I'll just put it 0. Flags. I think there is a flag that I need, which is ABS. Yes, I want the ABS because this is an absolute time. Does it work? All right. All of these, they are void, so they have no, because they are just filling the submission structure. I think I have to set the data for the submission to be my async. So this is how then I can find and match back my async that holds the completion callbacks. This looks fine. Maybe I can remove it as well. I mean, I don't think this is even tested in the test suite, but let's just add it. So timeout remove, I need another SQE. So even for removing things, you need to create a new submission and submit that. So remove submission. It wants the user data. All right, so async. Yeah, so IO, you ring, get data. Oh no, so I probably need just a reinterp, because the user data is a field of the SQE. Yeah, user data, it's unsigned long, so it's uint64. So yeah, the reinterpret cast, there's not much we can do about it. All of these C-level APIs, they are all about reinterpret casting things, because that's what they are. Flags, I don't think we need flags. Does it compile? Yes. Now sync with kernel. I have my uring, I have my event loop, I have a sync mode. So I should probably switch, and depending on the sync mode, I need to do things differently. So what are the sync modes? So we can either sync with the kernel in a no wait mode, which means we should not be waiting for a new let's say IO event to be fulfilled or completed. And to do so, well, what am I doing wrong? Oh, I'm missing this one. Okay. We have two functions. I think I should have been writing them. No. Oh yes, this one. So in the no wait mode, we call the IO uring submit, which, as you may guess, it will just submit the submissions that are in the ring. Maybe we can save the result. So this is just result. And when we need to do the forced forward progress, we do submit and wait. We want to wait for one more completion. So if result is minus then 0, not sure if we need to check also for the interrupt thing. Maybe yes. I think it's not documented. I've tried looking for that, but it was absolutely not documented, I think. Let me try to search again. So probably I'm going to, yeah, it just says on failure it returns or no. So, you know, anything can happen. Maybe let's do while true. Yeah, let's do it. If res is less than 0 and or no is interrupt. Let's send them again. Otherwise we break it. So if result is less than 0, return result error. Yeah, we'll just say that submit failed. Okay. If not, we are good. Yeah. So one thing I would like to do now is to copy the completions, or let's say to unload the completions out of the ring. And to do so, these are the functions that I found. So yeah, let's do that. Let's do a copy, I don't know, copy completions. Yeah, copy completions. So these are IO ring CQE events. We definitely want more than one. No, not total number. Events, yeah, why not? Static. Starting to read it. This VS Code is starting to read my mind on completing the variable names. And I don't have the copilot enabled, so it's kind of funny. There's no total num events here, so const exp int total num events, I don't know. Just a bogus number. Because this CQE is just a few, yeah, it's just 2 uint64 basically, so no problem in having all of these ones. So I should be peaking in batch so I can read many of them all at once. Event loop dot internal dot get dot ring, yeah. Maybe let's put the ring somewhere else. You ring into a variable. So I want to be reading these completions. So I need to have an array of CQEs, pointers. Oh, so it's returning the pointers. Yes, I remember because I've been researching also this. It's returning the pointers because you cannot just memcopy them, as they may be wrapping around the ring. Well, that's all right. I'm going to make it like this. Completions. So I'm going to make it completions. Yeah, the others of that. How many? This much. I think this returns the number of read completions. Big batch. Fills an array of IO completion up to count. If they're available, returning the count. Yes, does not wait. They have to be already available. All right. And num completions. All right. So I need to copy them, because then I need to send the ring buffer and advance the ring buffer, which means doing this CQ advance of the ring by num completions. Yeah. So here I can just for and a to 0. Is this unsigned? Yes. So maybe just idx. So in my events idx, I want to copy the completions idx, but this is a pointer, so let's copy it this way. Problem: missing braces. Oh, that's all right. Cannot convert ring to a yo-yo ring. Sure. We don't have an yo-yo ring here, of course. Cannot convert this. Okay, so we need to change the types on validate event and get async request, as they were integers, but they take the type of event, so they need to be IOU ring SQE. Yeah. CQE, sorry. And also for this one. So this is the one that takes a completion and gives us back the original async pointer associated to this async operation, and we associated with the set data, if you remember. Yeah, SQE set data, so we can do CQE get data completion. Yeah. This is probably a void star, so we have to should we reinterpret cast? But yeah, it's really, yeah. Actually, I think this should be a static cast. Async request return missing. Okay. Of course. All right. I need to fill this num events. So after I do this, I think I can say num events equals num completions minus, this is not even complaining. Should be doing static cast here. Anyway, so we can copy the completions. Yeah, let's copy the completions here. and we need to validate them. This is like continue processing. This is the same validate event as here. This is just telling if the event has errors and if it can continue processing. So if it's something that should really stop the processing of the event loop or not. So we can say if completion res is negative. Yeah. I think this is all right. Continue processing is true. So what else should I? Probably I should be handling more error conditions here, but I will do it later. Or maybe next time. How long is the video? 41 minutes. I should get at least one test running. Otherwise, this will be really bad video. So I'm preparing the timeout, setting the data, doing the completion, doing my fantastic reinterpret cast here with the expiration time. Let's try to run this. I mean, this will not work, but we can at least try to figure out what's going on. Yeah, let's run it. Run. Oh, I don't have the proper, yeah, GDB. No, wait a minute. This should not be running all of these tests. What's going on? Oh, yeah, I need to just do run async test report, run async test, and run async test. We clearly just want to run the loop timeout. Unspecified error. Excellent. Let's break it. Can we create the event loop at least? Okay, we can create the event loop. Can I create a submission? Yeah, we have a submission. There is a spec. We are doing this. Very good. Are we syncing with the kernel? No, we are still creating submission. Submit and wait. Result 2, which is okay. Copy completions. How many completions we have? 2. We have the completions, we advance, and we have the new events, which is 2. So why is this not good? Run step. Who's returning the unspecified error? Sync with kernel. Oh, it's returning false. Yeah, sorry. That's an unspecified error, of course. Try again. Can I just stop this? Run. Ooh. Does it really work? Let's try to make this 2 seconds. And this, I don't know, 3 seconds. Is it going to block for a while? Yes. Yeah, of course, the expectation is not fulfilled. Let's do report dot console print line timeout 1, and we do timeout 2. And use it parameter res. Let's make it bigger than 1. Timeout 2. Yeah, this works. Really nice. So the timeouts are working, which is cool. I mean, this is kind of nice API. I was not expecting this to work. But, you know, you just prepare a timeout, you set the data, you submit it, or submit and wait, and you validate it, and if it's right, it's right. Yeah, all of this works really so easily because all of the refactoring work that has been done on the async, which is not just a refactoring, I've been adding like a new state, so it's changing the logic a little bit, but it makes things a lot easier to follow. Okay, cool. I would say let's try to get the wake up. Yeah, maybe let's try to do the wake up. I mean, are we at 46 minutes? Yeah, we can do that. So to do the wake up, I need to do the file poll, I guess. So let's do the file poll first. So let me do a setup and tear down. Because I think the poll, from what I've been reading, does not need to be rearmed at every invocation. It will be just working as a regular poll. That's what it was written, I think, in the documentation. Oh no, that's the exact opposite. Okay, forget about it. We need to do the exact opposite. I don't know why I was remembering there was like that, but thankfully I have been taking a look at the documentation. So poll add, so this is file poll, async file poll, async. Poll remove. Yeah. So async, so we need a submission, create submission. Also here. Submission, we need a file descriptor, async handle. Poll mask. All in. No, doesn't have a handle. File descriptor. Okay. Well, poll remove, submission, and wants our user data. So yeah, again, this is the same as when removing the timeout. Poll-in was not declared here. So should we include sys poll? Yeah. Oh, it doesn't want it as a. Pull remove just wants that the user data as a void pointer. Why the timeout wants it as a user data uint64? I don't know. Don't ask me why. So to create the wake up, now I need to, what should I do? I think, yeah, I need to pull an event file descriptor. Yeah, so this is a way to create a file descriptor that you can use for synchronization events, but just, writing to it, and this will, get signaled as something that has changed. So yeah, why not? All right, so I can use this because this is not used. So this is my eventfd. Eventfd create a shared watchers. Yeah, I would do event. What is this? Sys event fd. Where is this defined? Yes. Eventfd count. Initial count, I don't care. Flags, I definitely want the clock second unblocking. So clock sec means this will not be inherited when forking this process. It will be closed when execute will be called, so it's non-inheritable. Okay. Yeah, return result error, and then I need to event file descriptor dot assign new event fd. All right. Let's see, try this. Does it compile? Yes. Let's create an async file poll to poll the fd poll, to poll this thing. Event fd file poll start on the event loop, file descriptor, new event file descriptor. So I guess, is this called by async? Yes. Event loop dot run. I think we need to do a run no wait, or run once actually. This is basically the same. I know just by heart because this is the same done here. Run once, run no. Oh, I'm doing a no wait. Yeah, I mean, I think a run once should work here, but let's not worry about it for now. So now we have a size mismatch, 296. 296, 296, and now it works. So I'm creating this shared watcher. I should also do do something about it? Probably not. Yeah. So in this callback, what should I be doing? So when polling this, I don't need to do anything, because the only reason for this to exist is to wake up the event loop. I just need to write here. So I can do internal get eventfd get eventfd and eventfd, and I can do eventfd write to eventfd value, I don't know, something. If I mean, I guess we need to do the do while res while res is -1 and erno is interrupt. If res is less than 0, return result error. Yeah. Oh, so on the poll, yes, we should be invoking the yeah, I think get event loop should be invoking the what's the name of that? I can't really remember. I need to make it part of that. I cannot make it in a lambda. All right. Yeah, because I don't have access to the private members. Yeah, I need to do it like this. Maybe let's call it in the same way, wake up poll. Yeah. Wake up poll, complete wake up. Let's just copy this. Yeah, we need to execute the wake ups basically. Wake up. Yeah, I was writing on the POSIX one to investigate the event FD, so probably we can backport it also to the ep.11 backend. No, I don't even need this. All right. I think I also need one more thing, which is yeah, in the activate and complete for the wake up, I need to add them to the linked list. This is very similar to what we do here. Yeah, this one. Let's save some typing. Very good. Let's see if this is now working. So loop, wake up from external thread. Yes. Loop wake up. Segfault. Async event index. So we have some async requests that are null PTR. Yeah. Which index is it? The 0. So we are forgetting to set the data pointer to some of them. Yeah, this one. IO ring set data submission async. Are we doing this everywhere? Yes. Let's try again. This works. Wakeup loop event object. Oh, that's beautiful. Beautiful. Let's try all of them. Yeah. All right. This is extremely exciting. So I think this can be enough for today. Video is 1 hour long. So yeah, I'm really happy about this. Really happy. So I got the timeout, the wake up, and wake up with event object running, which means also having the file poll. That it's going to be useful for the process exit, because even for the process exit, I will need to do something similar, which is a syscall to pdfd open, and this handle needs to be poll. So this is a really good start. I know I'm not really doing a proper job here in checking all of the error conditions, but I think I can improve it in next video. So that's all for today. Make sure to subscribe if you liked what you have seen. Make sure to join the Discord, because there's really a lot of very nice programmers hanging there and hanging around. And let's just make sure to keep in touch. Okay, so have fun. Make sure to download and clone Sane C library, and see you next time. Bye.